So the formal definition of integration goes a bit like this. So an integral written with like this is read as the indefinite integral of x to the power of n with respect to x. And that means that we are multiplying this function x to the power of n, which is dependent on x. So if x changes, it will change, and we're doing that with respect to as x changes. So in real life, that would be like speed, which is a function of time. We are looking at all the different time parts as it changes as time changes, right? So once you get your head around it, it makes a lot more sense. But how do we figure them out every time? So this is just the formula, if you will. So what you'll do is you'll increase the power of whatever it is in respect to. So if this was t, you'd have a t here. So you increase the power, and then you divide by that power. Then you add c, your constant of integration, to allow for any non-x terms, right? And n cannot be equal to -1 because -1 plus 1 would be 0, and everything to the power of 0 is 1. So that would kind of make the function fall flat. So that's why it's like that. So let's do some examples to cement this in. All right, so here we'll integrate the following. 5x to the power of 5, okay? So this becomes x to the power of 5 plus 1 all over 5 plus 1 plus c. This becomes x to the power of 6 over 6. And over here, you have the integral of p to the -2 with respect to p. This becomes p to the -2 plus 1 all over 2 plus -2 plus 1 plus c. So it's p to the -1 over -1 plus c, which simplifies down to -1 over p plus c. So that's it. So it's just like differentiation, but just the opposite way around. So do lots of practice and you'll get used to them, but that's the idea of how it works.